All right, welcome to another session of Math Workouts with Coach Payne. And today's lesson is going to focus on what are functions. And so, just to recap, we've been talking about what is calculus. And remember, calculus is the study of continuous change that we saw in lesson 1. Then in lesson 2, we talked about the different numbers of real numbers, I should say, and we were talking about rational numbers, irrational numbers, and how that's going to play a role into our functions when we're talking about domain and range. And then we saw last week, how do we simplify different type of expressions and how do we solve different types of equations? And so before we could get into this concept of functions, we need to focus on going back into what are relations. So let's get into what are relations. And so relations is where you have one quantity, typically denoted by x, relates to another quantity, which is typically denoted by y. And we denote that relation as an ordered pair. X relates to y, right? Relates. And so I will oftentimes use birding, and it's one of my hobbies here. And so I wanted to share with you this image of it's a swan and some baby swans. And so how would I use this as a relation? Well, what if we wanted to know if one quantity, let A, represent the baby bird's age in days, and let the second quantity, W, represent the baby bird's weight in grams. And so if we had a relation, that relation would denote the ordered pair A comma W. And so as we see that, relations, when we go back, there are 4 different ways we denoted a relation. Through a set of ordered pairs, we could use a table of values, we could use a graph, and notice how the graph axes is labeled with X and Y, or we could use a mapping. And so, now what we're going to do with that is now we're going to see how we're going to take that into relation of the functions. And so I'm going to be using various different texts, so I'm getting better at denoting that resource. And I want you to take a look here that one of the ways that we could see, if I move this image, there it is that informally. It's kind of math as a language. So you have to understand that how we speak and how we write, we have to be careful. So informally, we could think of a function as a machine, right? As a machine. And what this says here is that the machine is going to take these input values that come from the domain of your function, the domain, which is what all real numbers most of the time, however, could be limited. So you take those values, x is 1/2, x is square root of 2, x is -3/2, x is 0. Those x values go into this machine. That machine is to function, does its thing, and comes an output of a y. And so as we see here, that machine f of x could be, well, what if f of x is x squared? So that x value that happens to be 1/2 goes into the function of x squared, and the y value is going to result 1/2 squared is 1/4. A rational number went in, a rational number came out. And so the formal definition of this is you think of a function as a rule. This here, this you consider your rule. This is how your outputs are defined. And so what this is going to say is that rule here, that rule assigns to each object and set A, which is typically the domain, so this is coming from the domain, exactly one object in set B, which is the range. One object. So what this means is that this input value that goes in can only be assigned to one output value in order for it to be a function. And so I just want you to see that I'm going to be pulling different definitions from different resources. And look at this. A function is a relation. So you think of that a relation of A as the baby bird's age. See, a baby bird's age cannot correspond to two different weights in order for it to be a function. So it's what each input corresponds from the domain corresponds to exactly one output or element in the range. And this is the important aspect of it. Why do we use functions? Functions are used for predictability, right? We collect data, we get this data, and we say, what is this data going to tell me? So that when we're given these inputs from the domain, we're able to predict what this output is going to be at least 100%, right? And so here with non-functions, so relations, there are plenty of relations that are non-functions, but those relations don't have that predictability feature. And so, there are going to be some key components in terminology throughout calculus. So the independent variable usually represents the inputs, and the dependent variable usually represents the outputs. This is key here, right? So let's take a look here at an example. And I'm really big into this idea of, animals and whatnot. So functions arising in applications are not always given by formulas. Those formulas typically are f of x. You can have a data collection from observation or experiment define functions for which there may be no exact formula. That's why we have data. And so such functions can be displayed either graphically, right? We said by a graph or by a table of values. That's what we have here. And so this data, biologists, so I know that we have some bio majors representing. And so Julian Huxley, back in the day, this is a year before I was born, studied the antler weight of male red deer as a function of age. So in this case, I'm thinking, what's the independent, what's the dependent? We will see many tools from calculus be applied to functions constructed by data. So what they've done here is time in years are going to represent the inputs. The weight in kilograms are going to represent the outputs. So in 1 year, the male deer antler weight is 0.48 kilograms. Second year, 1.59 kilograms. So you could see as the deer, right, is getting older, the antler weight is increasing. And so in this particular case, write a sentence describing the function, provide a sentence describing the independent variable and include units, provide a sentence describing the dependent variable including units, and write a function notation. Functional notation, I'll just give you a hint because we're running out of my 10-minute time, is that if this was t in years, and W is the weight, the function notation could represent your output. Y is going to be a function with respect to t. So I would like for you to practice, right? The idea is to think about these ideas, and then we'll talk about them when we resume. Another one here that I'm just going to read is a producer and distributor of gift cards produces X boxes of cards per day at an average cost in dollars. Here they actually gave you the formula, right? Yeah, formula. We're not going to focus on this right now, but I want you to see that this is given by a graph. And so what we're going to do is at this here time 0, that initially, right, that you had the average cost, I'm guessing it's about a little over $26. And so as the number of boxes, the average cost is decreasing. And so again, write a sentence describing the function, provide a sentence describing the independent variable and include units, provide a sentence describing the dependent variable and include units, and provide a function notation for the function. And then when we resume, we will talk about those responses. And what I also want you to do is take a look here at what are piecewise functions. I want you to take a read of this. What are trig functions? I want you to take a read of this. And then how do we graph functions? Take a read. Look at all of these functions: linear functions, polynomial functions, power functions, rational functions, root functions, piecewise functions, trig functions, exponential functions, log functions. We did all of this. Elementary algebra, intermediate algebra, right? Pre-calculus, trig. And so if we're not brought up to our skill set, then that means that we're going to have to hustle. And so this is what the prep is getting ready for calculus to kind of fill in those gaps. And then I will see you on Friday to talk about some of these concepts.